Hello everyone, I hope you all are doing safe and sound. Welcome to my channel DevOps Tech Stack. Today we will start with the day 2 of the Kubernetes playlist. In this, we will basically go into much detail about the different components of the Kubernetes. But before getting into that, let's first discuss what we have discussed already in the day 1 video. So the very first thing which we learned in the day 1 video was what is Kubernetes. It is basically allow you to host your application in the form of containers in the automated fashion. You can go into much detail by watching our day 1 video of this series. Next, I explained about the typical metro train example. There I explained about the driver control compartment and the passenger filled compartments. What is the purpose of these two compartments? Why is it helpful? Then we went into the different control plane components like etcd, kube scheduler, different type of Kubernetes controller managers. Then what is Kube API server? Then what is the container runtime engine in case it is a Docker or Container D or Rocket, whatever it is. Then we discussed what is kubelet. And then we finally discussed about the kube proxy. Okay. And then I finally explained about the Kubernetes architecture diagram. So this is the very important thing. There is two type of nodes basically. One is master node, the other one is worker node. On the master node, you have control plane components like etcd, kube API server, kube control manager, kube scheduler, and container runtime engine. On the worker node side, you have the kubelet, you have the kube proxy, and you have the container runtime engine. So all these components we will go into much detail, but to deploy or install these many components on your Kubernetes cluster, we will cover that in the different lectures where we will try to set up the Kubernetes in the two ways. The one is the hard way setup of the Kubernetes cluster, and the other one is the kube admin setup. So those things we will go into much later in this course, not for now. But for now, we will go into detail of each of the components, whatever exist on the control plane component and the worker node. Okay, so today basically I will start with the kube proxy. What is kube proxy? Let me first explain that. So before getting into deep of the kube proxy, let's understand how does the pod to pod communication happens in case of Kubernetes cluster. So don't go into definition of what is pod and these things that we will cover in the next lecture. But for now, you are deploying your applications in the form of container, right? So if you have two pods, let's say you have this node 1 and then you have another node 2. These two are basically worker nodes. What is node? Node is just a server. Okay. So you have two servers, that is node 1, and then you have node 2. On both the nodes, you have pod deployed. Pod you can understand for now as a container. Means inside this, your application is running. So how are these pods basically connecting? Okay. So within a Kubernetes cluster, every pod can reach every other pod. So this pod on node 1 can reach to the pod on the node 2 directly. They can reach with their IP. Okay. So you don't have to worry about any networking solution. They can communicate directly through their IP. This is enabled by default. Okay. So this is enabled by basically a pod networking solution. Okay. This pod network is an internal virtual network spanning on all nodes. Okay. On all the nodes, one virtual network is deployed, which is helping to communicate these two pods deployed on the different nodes. And they can basically connect to through these networks and they can communicate through it. Okay. So just using the pod IP, they can communicate if all the nodes are on the part of the same Kubernetes cluster. Okay, understood? The very first thing is how does the pod to pod communication happens? You have two nodes, node 1 and node 2. On both the nodes, you have pod deployed. And how these pods are able to communicate? They are easily able to communicate through a pod networking solution deployed on all the nodes. You are not doing any other settings for this communication. It is enabled by default. This pod network solution you can't see because it is a virtual network deployed on your Kubernetes cluster. But they need to be the part of the same Kubernetes cluster. Okay. Now, now let's say there is on one node you have web application pod deployed. On the another node you have the database pod deployed. Okay. So how they can communicate? They can directly communicate through their IPs. So on the web application pod, this pod is having IP this one, and the other one is having IP this one. Now, web application pod can communicate directly to the database pod using the database pod IP. But this pod IP is not constant. Once the database pod is restarted, this pod will this pod IP will change, and then web app pod will not be able to communicate with the database pod. So this is the problem. Okay. So pod IPs are not guaranteed to be persistent, and if the database pod restart, its IP could change, breaking the web app. Okay. Understood the problem? They can easily communicate with the IP address of the pod, but since if you restart the pod IP will change and they can't communicate, and hence our application will not work, right? So now to overcome this situation, the concept of services came into picture. So basically you will create a service that will expose the database application, and now with the service name or service IP, this web app pod can communicate with the database pod in your application. Okay. The web application accesses the database by the service name. If you have created a if you have created a service with the name database to access your database pod, then this web app pod will communicate through that particular service name or the service IP. Also, the service get a stable IP address. Means this IP address will not change. Service has a constant IP address through which web app can access your database pod. Again, service is also a virtual kind of thing, okay? And it also does not have any interfaces or actively listening process. It is just a virtual component that exists inside the Kubernetes memory. It is not an actual thing, it is just a virtual thing that exists in your Kubernetes memory. Okay. So, in short, what you understood, that on one node you have a web application pod deployed, on the other node you have database pod deployed. These two can communicate through each other through the service which you have created or exposed for accessing your database pod. The service IP is constant, it will not change if the pod restart, and your application will not break with this change. Okay. You just need to create a service for accessing your database pod, and this will get a IP address, and through this IP address your web app pod can communicate with the database pod. Okay. So now let's understand what is the concept of kube proxy, where it comes into picture. So kube proxy basically cluster. So kube proxy is just a component that runs on every node of the Kubernetes cluster to allow the networking solution between the different nodes. It basically watches for the new services, like we created one service for the accessing the database pod. Then also it configures the rule on each node to forward traffic to the backend pods. Let's understand with this particular diagram what I meant to say. This is one node, this is the other node. Okay. On this node, you have the web application deployed. On this node, you have the database pod deployed. And the IP of this particular pod is 10.32.0.40. And the IP address of this is .15. Okay. On both the nodes, you have the networking solution deployed called as the kube proxy. Okay. This is the kube proxy solution which we have deployed on both the nodes. Okay. Now, what this kube proxy will do, it will create a network traffic rule that will route the traffic to the backend pod. Let's say if your web app wants to connect to the database pod, the service which you have created, right, for the database to expose the database app, you have created this particular service, right? So with this particular service IP and then the IP of this particular database pod, it will map one or create one network traffic rule. This is the service IP of the database and this is the pod IP of the database pod. Similarly, if database pod want to communicate with the web app pod, then again you have to give the service IP and then the pod IP of which one? Web app pod. Okay, so this kind of networking solution in the automated fashion, basically your Kubernetes is creating through the help of the component called as the kube proxy. So I hope now you understood the concept of the kube proxy. Now the question comes into mind, like how you are going to deploy these components onto your Kubernetes cluster. So basically we will have two types of Kubernetes cluster that we can create. One is the hardware where you are doing everything from the scratch, and the other one is kube admin setup, where that is one kind of solution that gives you a Kubernetes cluster. You don't need to do everything manually there. Okay. So if you go with the hardware setup of the Kubernetes cluster, then in that case, you need to download the binary for the kube proxy from the official Kubernetes page and then run that as a service. This we will go into much detail in the later course, not for now, but I am just explaining how you are going to set up it. But if you are going through the kube admin setup, you don't have to do anything. Kube admin, what it will do? It will deploy the kube proxy in the form of daemon set on all the worker nodes. Okay. So what it is doing here also, see, this is one node, this is the other node. On both the node, the kube proxy is deployed. So the component which is running on all the nodes, that is can be deployed as a daemon set, that we will go into later, like what is daemon set. But for now you can understand that if you are using the solution kube admin, in that case kube proxy is deployed in the form of daemon set automatically. If you create a new node also, in that automatically the kube proxy will come into picture and it will be deployed. You don't have to do anything because Kubernetes is doing everything in the automated fashion. Okay. I hope now you understood completely the concept of the kube proxy. Okay. Deep on networking and daemon set we will see later in this course, not for now. For this, the agenda is only to make you familiar with all the kind of different components that are involved in the Kubernetes, right? Now let's go into detail of the kube scheduler. What is this? So this is basically a control plane component that we already saw in the Kubernetes architecture diagram. So what is its main responsibility? So it is basically responsible for scheduling the pods onto the various nodes. Okay. It is not responsible for creating the actual pod. That is the responsibility of the kubelet agent. Okay. But it is basically assigning the pods onto the right node. So its duty is just the scheduling of the pod onto the right node based on the resource requirement. Okay. Responsible for deciding which node each pod should go on, ensures that the right pod lands on the right node based on the resource constraint. Okay. Now it also consider the node capacity, like what is the CPU, what is the memory, what is the RAM, everything it decide, and based on that, it will schedule the pod on the right node. Okay. Now, how does the scheduler identifies the right node on which the pod should go on? So based on two functionalities, okay, the one is the filtering, the other one is the ranking. That I will explain now. What is the filtering? It excludes the nodes that cannot run the pod. If you have, if your pod is having minimum 10 CPU requirement and your node is just having 4 CPU, then it will filter those nodes because it is not matching the minimum criteria on the for which on the pod should schedule on that particular node. Now, what is the ranking? Next, whatever the nodes are left onto your Kubernetes cluster, it will score the remaining nodes to find the best fit. So I will just explain you with one example, then you can easily understand this part. Let's go to this. Okay. Let's say you want to deploy a Java application in the form of pod, and for that the minimum CPU requirement is 10. And in your Kubernetes cluster, you have basically 4 nodes available. The one node is having 4 CPU, the other node also having 4 CPU, the other one is having 12 CPU, and the last one is having 16 CPU. Based on the filter nodes mechanism, it will first remove these two particular nodes which is not having the minimum CPU available. That is the 4 and 1 4. Okay. So node 1 and node 2 are removed before using the filtering mechanism. Then we are left only with these two options, node 3 and node 4. Then the rank node will come into picture, and using the rank node method, what it will do, like if it deploys this particular pod on this particular node 3, then this particular node will only be left with the 2 CPU, and the fourth node will be left with the 6 CPU. So this particular node will win because the maximum CPU which will be left on the node is the node 4. So this particular application will finally reach on the or schedule on the node 4 of your Kubernetes cluster. Node 1, node 2, node 3 are declined, and node 4 is the best fit where your Java application pod can be deployed. Okay. So these two are mechanism. Using those mechanism, your Kube scheduler decides the best fit for your pod on the Kubernetes cluster. Now you in the Kube scheduler you have few advanced scheduling options like resource requirements, limits, taint tolerations, node selectors, affinity rules. These things we will go into much detail in the later section of this particular course, but for now we can ignore these part. Again, for the installation part, you have two types of Kubernetes cluster setup. The one is the hard way, the other one is the kube admin way. In the hard way, again, if you are setting the Kubernetes cluster through the hard way, you again need to download, extract, and run the Kubernetes scheduler as a service. And you have to, while running this particular as a service, you have to create your own scheduler configuration file as the form of service. You have to do the daemon reload, and these things we will do in much later in this particular course. And if you are doing through the kube ADM setup, then you don't need to do anything in particular. This kube scheduler is automatically deployed inside the kube system namespace on all the control plane components. Once we have set up the Kubernetes cluster, I will show you the kube system namespace, and inside that your kube scheduler will be running. Okay. Now, all the manifests related to the control plane component are deployed on the master node inside one particular folder. You need to connect to the master node, and inside that you have to go to etc Kubernetes manifest folder, and inside that you can see all the manifests related to the scheduler, related to the control manager, everything you can find over here. Okay. Now, if you want to see basically on your nodes if the process for the scheduler is running or not, you can use the ps command, and there you can grep with the scheduler and you can see whether your scheduler is running on that particular node or not. Okay, now we will wrap this session, and today we have completed the kube proxy and the kube scheduler. What is the purpose of these two particular components? The rest components we will cover in the third lecture, and after that we will start with the actual practical implementation. Okay, thank you for thank you guys for watching our videos. Please keep subscribing to the channel DevOps Tech Stack. Thank you.